Guys, in class we've been looking at the oxidation of alcohols and we have performed an experiment to oxidize primary, secondary and tertiary alcohols. What we're going to be doing today is looking at the products of those reactions. If we then look at the oxidation of secondary alcohols are oxidized to a different product. So in a secondary alcohol, we have the hydroxyl group, which is on a carbon which is attached to two other carbons. When we oxidize this compound using, for example, acidified potassium dichromate or hot copper 2 oxide, the product that we get is a ketone, where in the place of the hydroxyl group on the second carbon, I now have a carbonyl group. So this group here is my carbonyl group, and I also lose a hydrogen from that carbon. So I'm decreasing my hydrogen to oxygen ratio or increasing my oxygen to hydrogen ratio. I have less hydrogens in this molecule than I did in the previous molecule. And as I mentioned, this C double bond O group is our carbonyl group. The product that I've formed here is a ketone. And the name of this product is propanone. So the ONE is telling me that this is a ketone. Lastly, what we're going to look at is the oxidation of tertiary alcohols. And tertiary alcohols simply cannot be oxidized. So we do not form another product when we react tertiary alcohols with oxidizing reagents such as acidified potassium dichromate or hot copper 2 oxide. The alcohol does not oxidize. So if we look at aldehydes and ketones a bit more closely, we find that aldehydes and ketones have the same functional group known as the carbonyl group, and that is this group that we see here. In an aldehyde, the carbonyl group is at the end of the chain, so we always see that carbonyl group with a hydrogen attached in an aldehyde. Also, another thing to mention is that aldehydes are given the suffix -al. So for example, alcohols are given the suffix -ol, propanol. Aldehydes are given the suffix -al, propanal. If we then look at ketones, in a ketone, the carbonyl group is now in the middle of the chain, or it is attached to two other carbons instead of a carbon and a hydrogen. So it's still a carbonyl functional group, but the position is different than what it is and an aldehyde. So ketones are therefore given the suffix -one, one-e, as opposed to aldehydes, which are given the suffix -al. Tertiary alcohols are not able to be oxidized, and this is because they do not have a hydrogen atom which is attached to the carbon. So we always have in a tertiary alcohol, the carbon that the hydroxyl group is on is attached to 3 other carbons. In order for it to be oxidized, the carbon that the hydroxyl group is attached to has to be attached to at least 1 hydrogen. So this is why we don't see tertiary alcohols being oxidized. So if we look at the aldehyde family or homologous series, I'm going to fill out the first 3 and then I will leave you to fill out the rest of the table on your own. So we have methanol. So if I draw the full structural formula first, methanol, we've got the carbonyl group and 2 hydrogens on either side of the carbon. So the molecular formula is CH2O, and shortened structural formula would be CH2O. For ethanol, ethanol is 2 carbons, so we have 2 carbons. It's an aldehyde, so our carbonyl functional group has to be at the end of the chain. So the carbonyl functional group is attached to a carbon at one side and a hydrogen at the other. And we can fill in the rest of the hydrogens so that all of our carbons have 4 bonds. So this is the structure of ethanol. Shortened structural molecular formula, we would have C2, we've got 2 carbons, 1, 2, 3, 4, we've got 4 hydrogens and 1 oxygen. And for our shortened structural formula, the first carbon has 3 hydrogens, the second carbon has 1 hydrogen and an oxygen. For propanol, we have 3 carbons in a chain, prop meaning 3 carbons. The carbonyl group is at the end of the chain, and we can fill in the rest of the hydrogens on the other carbons so that every carbon has 4 bonds. Molecular formula, we've got 3 carbons, 1, 2, 3, 4, 5, 6 hydrogens and an oxygen, and our shortened structural formula would be CH3, CH2, CHO. If you can look at your pupil booklets and if you can fill in the rest of those boxes by yourself, and we will check them in class. If we look at the ketones here as well, the full structural formula for propanone, now we don't have methanone or ethanone because the carbonyl group would have to automatically be at the end of a chain, making it an aldehyde and not a ketone. So the first member of this family is with 3 carbons, propanol. Now we don't have the double bond O at the end of the chain now, it's in the middle. And we can fill in the rest of the hydrogens so all of our carbons have 4 bonds. C3, H, 1, 2, 3, 4, 5, 6, O. So your aldehydes and ketones will have the same molecular formula as the other member in the aldehyde family. So for example, propanone and propanal have the same molecular formula. The shortened structural formula, first carbon has 3 hydrogens attached, the second carbon has your oxygen, and your third carbon has 3 hydrogens attached. For butanone, but meaning 4 carbons in the chain. Now we could place the C double bond O on the second carbon or the third. It would be the same molecule either way. So no matter if that C double bond O was on the first carbon, or sorry, the second carbon or the third carbon, it would be numbered if we were systematically naming it as on carbon 2. So this molecule is called butanone. C4, H1, 2, 3, 4, 5, 6, 7, 8, O. Shortened structural formula, CH3, CO, CH2, CH3. Now when we get to pentanone, we could have pentan-2-one or pentan-3-one, having the carbonyl group on carbon 2 or carbon 3. So we have to specify where the carbonyl group is, and this molecule has it on carbon 2. So if I draw my 5 carbons, carbon 2 is where my carbonyl group is, and I can fill in the rest of the hydrogens. We've got 5 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. Oh, so we can see a pattern with our molecular formulas here. Every time we add a carbon, we're adding 2 hydrogens. Shortened structural formula, CH3, CO, CH2, CH2, or I could shorten that down so it fits in. Because I have 2 CH2s in a row, I can have CH2, 2, CH3. That might become easier when you start to do your shortened structural formulas of the rest in the table. So can you fill in the molecular formula, full structural formula and shortened structural formula for the rest of the molecules in that table, and we will check them in class. For the pupil booklet questions, we have 2 questions. The first one is to draw the structures of some aldehydes, and the second is to draw structures of ketones. I'm going to go through those questions and the answers to them just now, so if you could pause the video just now and attempt the questions, and then you can follow through the solutions with me. Our first question, we've got, draw the full structural formula of the following aldehydes, and the first one is 3-methylbutanal. So butanal, 4 carbons. Our al means it's an aldehyde, so our carbonyl group is at the end of the chain. And if I'm numbering it with the carbonyl group being the most important functional group in the molecule, I would have carbon 1, carbon 2, carbon 3 and carbon 4, meaning my 3-methyl, my side group, will be on carbon 3. And then I can fill in the rest of my hydrogens here. For 2,2-dimethylpropanal, prop, 3 carbons in the chain. Al means it's an aldehyde, so carbonyl group at the end of the chain. 2,2-dimethyl means I've got 2 side chains, both of them on carbon 2, and I'm filling in the hydrogens for the rest of my carbons in the molecule, making sure every carbon has 4 bonds. And my last molecule is 3,4-dimethylheptanal. Hept meaning 7. 1, 2, 3, 4, 5, 6, 7. Al is an aldehyde, so the double bond O goes at the end of the molecule. 3,4-dimethyl, I'm counting from the side that has the carbonyl group because that is the most important functional group in the molecule. Carbon 1, carbon 2, carbon 3, carbon 4. So there's a CH3 on carbon 3 and a CH3 on carbon 4, and I can fill in all of my hydrogens for the rest of my carbons. So check your own and make sure you've got them all correct. Give yourself a little tick if you've got them all correct. The next question asks us, draw the full structural formula for the following ketones. And the first one we have is 2-methylpentan-3-one. So pent meaning 5, 1, 2, 3, 4, 5. 3, so my carbonyl group is on carbon 3. and 2-methyl. So no matter which way, because my carbonyl group is in the middle of the molecule, I could number my carbons from left to right or right to left, and my carbonyl group would still be on carbon 3. So if I number it 1, 2, 3, 4, 5, 2-methyl, I'm putting my methyl group on carbon 2 and filling in the rest of my hydrogens. For B, I've got octan 3-one, so 8 carbons. I've got my carbonyl group on, meaning I've got a ketone. Carbonyl group is on carbon 3. And I have nothing else in my molecule here, so I can just fill in my hydrogens, making sure every carbon has 4 bonds. And then lastly, we've got 3,4-dimethyl heptan 2-one. Hept meaning 7. On meaning I've got a ketone and the carbonyl group is on carbon 2. And then 3,4-dimethyl heptanone. So I'm just filling in, I've got my side chains on carbons 3 and 4. And I am just filling in the rest of my hydrogens. And that's this. You can check your molecules against my molecules and give yourself a tick if you've got them right. And any questions you can ask me on the Google Classrooms. Have a lovely day, guys.